This is my COMP3011 search engine. It crawls quotes.toscrape.com, builds an inverted index and let you search it from the command line. So I've already built the index previously, so I'll load it now. The print command shows the full index entry for a word, its frequency and exact position on each page. So print life and then print indifference. The find command returns all pages containing a given word. With multiple words, it uses and logic, so only pages containing all terms are returned, so the results narrow down. It handles edge cases cleanly. Missing words and empty queries don't crash the program. And the search is case insensitive, so these two will return identical results. The project is split into 3 modules. Let me walk you through the key design decisions. So index.py, the inverted index is a nested dictionary. It maps the words to word maps to all, and which maps to frequency and positions, and I chose a nested dictionary over a flat list because it gives all one lookup by word and all. Storing positions means I could extend this to like phrase search in the future. The crawler uses a queue-based BFS approach. It tracks visited O's in a set to avoid revisiting pages. All network errors are caught, so a single failed page doesn't stop the crawl. The 6-second politeness window is enforced with time.sleep between every request. So multi-word, where is it? Alright, so multi-word find queries use set intersections, and I get the set of pages for each term and intersect them. This naturally implements AND logic and is efficient regardless of how many terms are in the query. So for the tests, I wrote 62 tests across 3 files covering the crawler, indexer, and search engine. Network requests are mocks, so tests run without hitting the real site. cd ... Wait, let me exit. The tests cover normal cases, edge cases like empty queries and missing words, and things like the politeness window actually being called. And I used Git throughout the development with regular commits at each stage. And I used Claude as a Gen AI tool throughout this project. It was useful for generating the initial structure and boilerplate, but it wasn't without problems. For example, when I refactored method names like renaming get word entry to get entry, the test file still referenced the old names, and I had 14 failing tests. I had to go through the errors and fix the mismatches myself. The error messages in the test also didn't match the actual output. So the tests were checking for the word error, but the code said please enter, so those failed too. Understanding every line was important because the marker can ask about any of it. Going through and fixing these issues actually helped me understand how the modules connect. Overall, GenAI sped up the scaffolding, but the debugging and understanding was still on me.